sequence, a function whose domain is the set of natural number and range is the set of real number, is called sequence or real sequence. It is denoted by un, where un is the nth term of the sequence. For example, 1, 1 by 2, 1 by 3, this is infinite sequence. Convergent sequence. A sequence un is called convergent if limit n tending to infinity un is equal to L, unique and finite number. For example, n divided by n plus 1. If we apply limit n tending to infinity, n divided by n plus 1, we divide numerator and denominator by n, then we get 1 divided by 1 plus 1 by n. As n tending to infinity, 1 divided by infinity gets 0 and 1 upon 1 plus 0 is 1. This is finite value. Here this sequence is convergent. Divergent sequence. Limit n tending to infinity, un is plus infinity or minus infinity, then the sequence is divergent. For example, this n square, if we increase the value of n, this sequence goes to infinity. Oscillatory sequence. If a sequence un which is neither convergent nor divergent, then this is called oscillatory sequence. For example, minus 1 plus 1, this is the example. Monotonic sequence. If a sequence un is said to be monotonically increasing, if un plus 1 greater than un for all n, and said to be monotonically decreasing if un plus 1 lesser than or equal to un. That means next term is lesser than previous term. Here next term is greater than previous term. For example, this n upon n plus 1. If we replace n by n plus 1, we get un plus 1 and find the difference of un plus 1 and un. We get this expression. After simplifying, we get this is greater than or equal to 0. That's why this is monotonically increasing. Bounded sequence. If all term of the sequence lesser than any finite value, this is called bounded above sequence. And if all the term of the sequence greater than any fixed value m, this is called bounded below sequence. 1 plus 1 upon n is bounded above. Here upon bound is 2. That means all the term are lesser or equal to. Prove that this sequence is convergent. We find un and un plus 1 and check this difference is lesser than 0. Therefore, this sequence is monotonically decreasing and limit n tending to infinity un. We divide numerator denominator by n. We get this, and we divide numerator and denominator by n square. Then we get this expression, and by n tending to infinity we get here 0. So the series is convergent. Now we discuss about convergence of this sequence. At first we check un plus 1 minus un. We get positive number. That's why this series is increasing, monotonically increasing. And because limit n tending to infinity, we get here 0, or we check all the term are lesser than 1. That's why this is bounded above sequence. and we say the series is convergent.